Okay, so welcome to Module 3, Part 1 in AI engineering. So today we will talk about, in this module, we will talk about AI in large systems. You can see that nowadays there are integrations of AI with other technologies, and that makes AI more interactive, that gives more application to AI. So mainly there are many directions of AI. For example, there is the integration of AI with large language models, with natural language processing, and these natural language processing process the language, the voice recognition, whatever voice to text, and then we'll feed this text to the AI to do the job like recognition or analysis or something. So also, um, for example, the computer vision, when a camera takes pictures and then give it to AI, and there are several other processes and then process steps, and then this go to the AI. So actually, it's the integration with other technologies. It is like the technology will be an input to the AI, or it will be an input and output of the AI also from the AI. So for example, in the manufacturing optimization and robots, for example, the robot doing something, this gives an AI, or the AI give an order to the robot to do something, and then this action or this function will give a data to the robot again, and then based on that, the robot decide on the next step. So this is also a kind of integration to the other technologies. So basically, this integration gives us opportunity for this cloud and edge. So edge, basically cloud and edge, I'm sure many of you know this, but just to know that edge and cloud are complementing each other actually, and they are not separated. So the edge is just like a cloud, but bringing the technology or moving the intelligence to the edge means letting the edge to process the data and doing the processing without going to the cloud. So that will reduce the latency, and then this is bringing the computation power closer to the source. So that is used for IoT, Internet of Things, and Internet of Things devices, gateways, and also used for smartphone, for example. So a lot of intelligence are on our computer without going back to on our devices, like for example, on our iPhone without going back to the cloud. And cloud, of course, you know that it's an enabler of edge, and it has a lot of computation in the cloud, on the server somewhere else, not on your device. As I said, they are complementing each other. So there's edge AI, which means also that is used for the integration with the larger system. There is an edge AI, which is basically an AI that designed to run on the edge device. This is like deploying the machine learning algorithms and AI technologies on smartphone, for example. So that is the edge AI. So this is reduce the need for data processing, transmitting all the data to the cloud and coming back to the decision. Sometimes your internet is not good and so on. So that's a lot of latency. And in this edge AI technology, the decision is more efficient. Examples, of course, as I said, smart home building, for example, the edge AI monitoring the energy, doing a lot of things without going back to the cloud. And there is in healthcare, for example, there are devices to monitor patient health, and giving alarms and so on. And autonomous vehicle, not all the time these vehicles are connected to internet and they are autonomous by themselves, but there are a lot of intelligence there. So that's an edge. Industrial setting, also there are a lot of industrial setting for this. Cloud AI, of course, that's another higher level of AI. So all the AI technologies are in the cloud. So this will give you a lot of computation. Then the algorithms are there, and also um, you can process larger amount of data, and you get more computation. Of course, more computation and larger amount of data means more payment. There is no free cloud. So you have to pay, and this will come with more functionalities. As more as functionalities you want, as more payment you have to do. But in general, that's also give the organization, if you are belong to a big organization, this gives you the access of the cutting edge technology, and every time there's an update by the company, you get it immediately on the cloud. So this is used by the banks, for example, for fraud technology when you have many customers. This is used also for analysis of patient data in healthcare. You can see it also a lot in e-commerce and manufacturing. So there are many platforms and infrastructures nowadays, but there are let's say 3, 4, or maybe 5 big names in the market that controlling almost 80% of the market. So Amazon Web Service, you have AI, a lot of AI services in Amazon Web Service, and this gives you a lot of functionalities for the data scientists, for the developers. You get many AI services, healthcare, industrial equipments. Um, you just need to contact Amazon and get the services and pay for them. Google Cloud is also some other technology, and they have a lot of standardized things. AutoML, deep learning, and all these things are available. TensorFlow, for example, Azure, Microsoft by Microsoft. Also, that's something. IBM Watson also is another thing. So of course, these platforms, they provide some free services just for limited time or limited space, just to let you know how it works. And then if you want more services, you have to pay for them. Another thing which is very important nowadays is embedded AI. Embedded AI is just kind of AI integrated directly to a hardware device. So microcontrollers or sensors. It is just smaller scale. Also there is this auto ML. Sometimes they tiny ML, not auto ML, but tiny ML also is a kind of embedded AI. So you can see that here you have the device, you have AI functionalities, and then this goes to the computing power module, and then you have data module and the model module. Um, it's very important for real-time processing of data, faster, more efficient. It reduced the need for data to be transmitted to a centralized local. Is a kind of edge, but it's not edge. There are limitations because the computation power is not that much here, but in the edge could be good computation power. Of course, it's used for sensors, for example, smaller scale, as I said, small parts of the vehicle, also healthcare devices, industrial setting. there are three things actually in the embedded AI. You have model module known as the algorithm module that contain all the models. You can plug in these, you can upload these models, update them as you want, and depends on the capability of the device, of course. And you have the data module, obtain and process the data and manage the massive data required for all AI functionalities. And also you have the computing power module in the embedded AI that will take care of the inference, which means that providing the service or the functionality to the user or to the device, and choose between the models in the model module. So that's also something can be done will be done inside the embedded AI.